Hi class, welcome to the first lesson of chemistry. In this lesson, we are going to look at and identify the base units of measurement and convert between metric units of measurement. It's important to remember that here in science, we use the SI system or metric system of measurement. No Fahrenheit or inches for us. Now you'll be watching many videos as we move throughout this course. And as you watch this video and every other video, you want to make sure that you're following along and filling in the notes on the guided handouts you've been provided. Additionally, you want to make sure that when you watch these videos, you have the same tools you'll have with you in the classroom, which include a scientific calculator and a chemistry reference table. Lastly, remember that as you move through this video, there will be some questions asked of you. Answer those questions to the best of your ability. Your guided notes and your answers to these questions will be graded. Don't worry, you do not have to get all the Edpuzzle questions correct in order to receive 100 on this assignment. You do have to attempt them all, however. Since this is our first lesson in chemistry, it's important to understand what is chemistry. Chemistry is defined as the study of matter and the changes it undergoes. Now, matter is anything that has mass and takes up space. If something has both mass and volume, we may have learned in middle school that it will also have density. So we can say matter is anything that has density. Now, chemistry is not only the study of matter, but it looks at the change it undergoes. And that change could either be a physical change where the matter is simply rearranged, but its identity, its formula, and its names are constant. For instance, when you freeze water, you still have water. So freezing is an example of a physical change. Or matter can undergo a chemical change. That's a change that makes or breaks chemical bonds. We'll look at chemical changes such as burning throughout the year. Chemistry, like most other sciences, involves experimentation. When we carry out experiments, we have to measure the quantities of matter or material that we use. We're going to calculate results and compare those numbers to known numbers or to our hypothesis. In all science, all measurements must include a number or quantity and a unit that describes what that number is. Here you can see a few number and units that accompany measurements. Now, some of the units you might be familiar with, but all of the units that we'll use in this class will be found on reference table D.
Now you might know that gram measures mass. But did you know that mole measures amount? Or joule measures energy?
When you are watching these videos, you want to make sure that you're following along and completing your guided notes, which will be checked for completion in class. There will also be some pop-up questions that check for understanding on the way. These questions will be graded for both completion and accuracy. Now don't worry if you get a few wrong, as you can still receive full credit on the assignment. It is important that I get feedback so I know what areas you are comfortable with and what areas you need a little bit more support. Now we're going to talk about how to use a power of 10 number line. The SI system of measurement, or the metric system, is unique and that is based on the power of 10. So each metric unit typically has both a prefix that indicates the power of 10 and a suffix that indicates the type of measurement. For instance, gram for mass or joules for energy. For instance, here we have two masses. We know that these are both masses, as indicated by the suffix for grams. But these are very different masses, as one mass has no prefix, no power of 10, the grams, versus the other mass, the milligram, has a power of 10 that matches 10 to the negative 3. Therefore, it is actually 1,000 times smaller than a gram. Most of the medicine we take is prescribed in milligrams and almost never in grams. If you accidentally took a gram when you were supposed to take a milligram, you would be taking 1,000 times greater dose than was prescribed. There are many ways to convert between metric units of measurement, though I have found making and utilizing a power of 10 number line to be the easiest technique. Write down these 3 steps so you know how to use the power of 10 number line. The easiest way to make the power of 10 number line is to start with reference table C and simply turn it so that it is on its side, so the powers of 10 are down at the bottom. With your reference table oriented like this, you can see the makings of the number line. Now, one important difference between the number line that you will use and the number line that is just your reference table turned on its side is that it's important to have one tick for every power of 10. So notice on your reference table, you go from a 10 to the third down to a 10 to the first, and there are no actual ticks for the measurements in between. It is important that, like the number line at the bottom here, there's one tick for each and every number. It is not important, however, for you to know the prefix name associated with a tick not listed on reference table C. Again, what we have here is a number line from the greatest power of 10, 10 to the third power, to the smallest power of 10, 10 to the negative 12th power, making sure that a tick is provided for each number in between. Our base unit, our unit without any prefix, like a meter, liter, or gram, also known as 10 to the 0 power, must be included. Now there's a mnemonic device that some people like to use to remember the order of the powers of 10, but again, as long as you turn your reference table on its side, so the spine of the reference table is at the bottom of your desk, you should be able to get this in the correct order. The mnemonic device reads, King Henry died unexpectedly drinking chocolate milk with 1, 2, 3 monks, 1, 2, 3 nuns, and 1, 2, 3 priests. When using the mnemonic device, each word corresponds with a prefix. In addition, when we get to the smaller units, it's important that we say 3 monks, 1, 2, 3 nuns, and 1, 2, 3 priests, because we need those ticks for the power of 10, even though they do not correspond with a prefix. Let's discuss how we'll use the power of 10 number line with 3 examples. The first thing we need to do is decide our starting and ending points. In this first example, we will begin with the milliliter and end with the liter. Down on our number line, we see that milli corresponds with 10 to the negative third power, and liter has no prefix, so it's a base unit, or a 10 to the 0. That means we are going to need to move our decimal place 1, 2, 3 spaces. Now, since we're starting at milli and we're moving towards liter, we're going to actually move our decimal place 3 spaces to the left. In the number 68, our decimal point is actually here, to the right of the number. And if we move the decimal place 3 spaces to the left, we'll go 1, 2, and now we're out of space. So we'll add a 0 and drop our decimal point. So our answer is 0.068. In chemistry, it is good practice to place the leading 0 for numbers less than 1. We are going to use the exact same number line and the exact same technique for the next 2 conversions. Let's begin with the conversion from nanograms to milligrams. We can see that a nano is synonymous with 10 to the negative 9, and milli is synonymous with 10 to the negative 3. So we must move our decimal place over 1, 2, 3, 4, 5, 6 spaces to the left. Since the decimal point begins here, we're simply going to have to add more zeros until we move the desired number of spaces. 1, 2, 3, 4, 5, 6. We'll drop our decimal, and it's always good to add a leading zero. To make sure that the next measurement shows how this technique can be used to make numbers both larger and smaller in unit, let's make a little change to the problem first. Let's change picometers to centimeters. Now when we look at our number line, if we want to move from centimeters to millimeters, we can see that they are only one space apart. But to move from a centimeter to a millimeter, we're going to have to move to the right. So we'll move our decimal place one spot to the right. Since our decimal spot begins to the right of this number, we're going to have to add one more zero and drop our decimal point to the right. Now you try a few practice problems and see if you've mastered this conversion.